Hi, okay, this video is about my control panel for the layout, the railroad. It's February 26th, 2018, and this is the panel here. This is what I got. So this is a wooden box that I got from the dollar store. It measures, let's say, almost 6 inches by 2 by 9. Yeah, 6. 6 by 9, 2 inches deep. So here I printed the schematic of the layout, so that's what the layout looks like. Here's a close-up. Hard to see where I'm pointing this thing. There we go. And the camera is, what do they call that? It's a mirror image, so it's hard to figure out where you are. Hopefully that's clear. Okay. Um, so I got these push buttons from, I'll show you. These are push buttons with the LEDs built in, green. They're about $3, 3 something each. So it's a lot of 20, 28, 29 push buttons I have. So there's 4 pins on the button, 2 for the push button and then 2 for the LEDs. So I'm running a common for the push buttons and then a common for the LEDs. So, but it's a separate common. I think it's a positive common for the LEDs and a ground common for the push buttons. This way I can use different voltages. The other thing is the power it's getting is from the Team Digital boards. That's what I'm running in this guy. The other thing about these guys is that I have to install these. There has to be some smarts in the commands in this box, because what happens is, let's say you take a route, you take the route A. So then now this light will come on. Then you take the route B. So when you select that one, that light should come on. This one should go off. And so forth. It should cascade all the way up to the top. So as I jump, the different lights will come on, and whatever was off, whatever was previously on, has to turn off. And so that's smarts for there. And then same thing for other yards. Sometimes there's a combination of let's say I'll select this push button in here. So this guy will come green. What happens? It'll select this whole route to come out to here. But let's say one of these push buttons, like the previous one of these routes was selected. Well, when I press this button, whatever was selected there has to turn off, because I want to select this one. So there has to be all these kinds of smarts going on. Same thing for up here. Here I have 3 tracks. So depending on which track I take, the other one has to go off. So there's all kinds of logic that has to be figured out. In this case here, it just toggles between one or the other, so it doesn't think about other routes. But for instance, this one does. If I select, let's say if I've taken this route here, or this route, or this route, they'll turn on between each other. But then if I select this one, any one of those 3 that are on has to be turned off. Same thing for let me see. If I selected one of those 3 routes, and then I want to select this route over here, well, what happens is the train would be coming over here. So this route turn out the switch, which goes to one of those 3. So then now any one of those 3 or this one, if they're on, they have to be off. So there's all that logic involved in there. I'll show you the inside. So the inside here is what the board looks like. So I'm using Team Digital circuit boards. This first one here is, even though they look identical physically, there's different software on the microprocessors. So in this case, this one has 16 inputs and 16 outputs. So inputs for the push buttons, outputs for the LEDs. The next one has 8 inputs but 24 outputs. So 8 less inputs but 8 more outputs than this board. And then here will be a third board, which will be the same as this one, called the SIC24E, which has another 8 inputs, 24 outputs. Because altogether I have 29 switches or push buttons, and then I have 29 blocks. So to see if the train isn't, if the block is selected. So 29 LEDs to show that the block is selected, but then I need another 29 LEDs that will be red that are not part of the push button. There's separate LEDs that will be in the board, and those LEDs will tell me if the block is occupied. So then that becomes another bunch of logic that's involved, because the lights going on and off here are directly related to the push buttons, but the block detection, I might not have let's say I might not be selecting a certain block, but if there is a locomotive already sitting in that block, I want to know about it. So it's irrelevant whether or not the switches are pressed. It all depends now on block detection. If there's a train in there, it's red, and if there's none, then it'll be off. So the green LEDs for saying route selection, the red LEDs for saying block occupied. So then you have to have all that smarts logic installed. So now the way that logic is sent to this board is through LocalNet protocol. So what happens is, in this case, I have a connector here on the bottom. This is actually an RJ45 connector, which is 8 wires instead of 8 wires instead of 6, because the LocalNet requires 6. But what happens is I also want to bring power to this. So I don't want to have one RJ12 connector, which is the 6-pin telephone type jack, and a power. This thing uses low power, so I can just, what I'm actually doing is at the layout side, I'm putting the power on the RJ45 connector. So the six pins that go to the LocalNet, they use the RJ45, which is the 8-pin jack. But then I'm putting on the 2 outside pins, which is pins 7 and 8. I'm bringing power. So then what I'm doing is in here, I'm actually I have the RJ45 connector comes up, then the 2 wires come into this connector here, and then from there it just dumps to the next one, jumps to the next one. But then there's a RJ45 cable that plugs into here. It's a little hard to see. It plugs into there. So that's my RJ45 LocalNet RJ12, sorry, which is the LocalNet connection, which then daisy chains to their boards. So now what happens is, physically on this command station, the power is brought on that RJ45, which is the network cable, and the LocalNet information is brought on that cable. So you have one network cable plugs in to this board, and that's it. So now what happens is I can actually, put the long cable, go to the store, buy a 10-foot, 5-foot, 15-foot plug cable, plug it in there, and bring this around the layout. So that's it. Put it all together, put it in the enclosure. So now what happens is I can walk around the layout, flip my switches, or I can have it stationary in a panel. But what's neat here is that even though I have 29 switches and then 28 LEDs and then another 28 LEDs for the block detection, all that stuff is physically in this one box, and it's only connected to the layout with this one connector, one cable. So that gives me a lot of flexibility. The other thing is that the smarts that's in there allows me to, if I actually built another one of these boxes, I can have them in another place on the layout. And as you press these buttons and the lights come on and stuff like that, and obviously the turnout switch, and you can also tell where the locomotive is, that information will be duplicated on the other box. So if I have 2 boxes, 3 boxes, 4 boxes, you have to put all the circuits, you have to build them all identical. They all have to have the same boards and all of that in there. So, but then the information on the processors are just copied to the other boards. So if I hit this turnout here for this route, what happens is the light will turn green here, but then the light will turn green on the other panels. And then because it's LocalNet, the information will also go to the command station. And if you have a PC interface, it'll go to the the PC, and the PC will have the information. Or if I'm using, let's say, GMRI or train controller on the PC, and I trigger this route, well then physically what's going to happen is this light's going to come on. I won't press it here. I'm pressing it on the computer, but it's coming on here. Same thing for the command station. From the command station, I say, flip route A, this light will come on. Flip route Y, Z, whatever the different routes, the lights will come on. So what happens is it's getting information, feedback is getting and sending information to all the boards are all connected to each other, to the computer, and all of that. So there's all this two-way communication going on, which is really neat. because the thing is, and then usually what happens, and then yeah, the other thing I wanted to point out is, see these the turnouts, the push buttons are for the routes and not for the individual turnouts. Which means, like, let's say for instance, I want to select this push button over here, this route over here. All I do is I just press one button and that's it. A lot of the panels that the guys, most people build, is they'll have a switch for every turnout, a left and a right for every one of the turnouts, and that's a lot of complexity. All those switches have to be all wired up, and then they have an LED for each section of each direction of the turnout, and that's making it very cumbersome, the layout and your diagram. So what happens? Let's say you have a block up here that you're taking, and it requires 5 turnouts to be switched here, and another 5 turnouts here. Well, you're flipping this one. Okay, I have to flip that one up, and this one up, and that one up. You have to make sure you don't forget one of them, or else the train won't end up going there. So that's, again, a lot of complexity. You're looking always at the panel and stuff like that. You're not paying so much attention of the layout. You have to think about where it is you want to go. But when you have like this routing, you select one button, and then all the turnouts flip, and then that's it. You don't have to worry about it. And then since it is selected, what happens is the light will come on, so you know that it was the information. You can have feedback information from the turnout decoders to say, yes, I was flipped in that direction. So it checks to see that it was flipped. And if they are all flipped, then the LED will turn green. It doesn't turn on green just because you press the button. It turns out green because that route is actually confirmed to be selected. So that's what's the smarts about that. And again, just one wire, and it can move it all around the layout. What was the other thing I wanted to talk? Yeah, so there was that. So that's it, Team Digital Hardware. I'm building it. I just got to do a couple more wires on the wire up some more of the switches, and I'm gonna end up doing another panel, maybe smaller, or again, it's versatile. You can make another panel to do more or less the same thing. So that's it. Thanks for watching. Thanks for this is the update on that panel where I am now. So that's it. Bye.